Today in Algebra 1, Chapter 6, Section 3, we're going to solve multi-step inequalities. In this example, it's just like Gabriel's favorite thing to say in class. It's a two-step problem. It's no different for an inequality than it is for an equation. We have our left side of the inequality symbol and the right side. So we're going to add 7 to eliminate our 7s here. So we add 7 to the right. So we have 3x is less than 15. Okay, x is being multiplied by 3, so the inverse operation is to divide by 3. So you have x is less than 5. You want to put that on a number line. I'm looking for the number 5. I'm looking for an open dot, and I'm looking for it to go to the left. Here's a second example. Again, this is going to be a two-step problem. Here's our left side. Here's our right side. We need to isolate the term that has the variable in it, so we're isolating the negative 6y. To get rid of the positive 5, we are going to subtract 5. If we subtract 5 from the left side, we subtract 5 from the right side. That leaves us negative 6y is less than or equal to negative 21. Okay, now we're going to solve for y. Y is being multiplied by negative 6, so we will divide by negative 6. So we will divide the other side also by negative 6. Remember, when you multiply or divide through an inequality, the symbol must immediately change. Negative over negative turns positive. 6 divided by 6 is 1. So you have y is greater than or equal to 21/6, which reduces to y is greater than or equal to 3.5 or 3.5. Here's one more example. We have the left side of the inequality symbol, and we have the right side. We need all the variables on one side, so I'm going to take the 2x and move it over with the 6x. So I'm going to subtract 2x from the right side to make that go away. So I'm going to subtract 2x from here. So 6x minus 2x is 4x. That puts all my variables on the left. Then I want to put all my constants on the right. So how do I get rid of the negative 7 right here? I'm going to add 7 to make that go away. So I'm going to add 7 to the right side. So 4x is greater than 24. Now I'm going to divide the left side by 4, so I divide the right side by 4, and we get that x is greater than 6. We graph that, looking for the number 6, looking for an open dot, and looking for my arrow to go to the right. Here we have two more examples, and they're going to be special cases. In red, we have 14x plus 5 is less than 7 times the quantity of 2x plus 3. We need to simplify this before we go any further. So the left side, 14x plus 5, cannot be simplified, but the right side, the 7 can be distributed, and that will give us 14x minus 21 when you distribute that 7 to each one of those numbers. Okay, so here is the left side of our inequality, and here is the right side. So let's take this 14x and subtract it from over here to make it go away. So we'll subtract 14x from the left side as well. When that happens, x's on both sides of your inequality are eliminated, and you are left with 5 is less than negative 21. When this happens and you have no variables left, only constants, then you have to take a look at the constants and say, okay, does this make a true statement? Is 5 less than negative 21? And the answer to that is no. If the answer that you get when you have no variables left is no, then you have no solution. So when you're graphing no solution, it's just an empty number line. No solution. In blue, we have another inequality that's going to be the other extreme. Again, we are going to simplify this as much as we can. The left side is 12x minus 1 is greater than. We are going to distribute the 6 to give us 12x minus 6. Here we have the left, here we have the right. So we're going to take this 12x and subtract it to make it go away. So then we have to subtract it on the left side as well. So again, that eliminates all of the variables, and it leaves you with negative 1 is greater than negative 6. And you say, does this make a true statement? And the answer to that is yes, it does. When the variables are eliminated, and the numbers do make a true statement, then your solution is all real numbers. So you have your number line, and all the numbers on it, every real number that we have is a solution. So then your number line is covered completely like this, and it shows that all real numbers. And you can use a capital R for that if you want to, or you can write out all real numbers. So the only thing that we have added today is that we can have a no solution as an answer, and we can also have all real numbers, which can be a capital R, or you can write out real numbers. Okay, also you need to remember that when you multiply or divide through an inequality by a negative number, you must switch the sign. Hope y'all have a great day.